So welcome to my walkthrough for the Edexcel Higher GCSE. This time we're looking at January 2019, and be careful because it's not paper 2, it's paper 2R. So they're all calc aloud, so let's go. So skip the formula page. Happens quite a lot on these papers. So they've done the old putting the tables to the left, giving you room to create your own. How you set it out is entirely up to you. Simply make a little column and multiply the frequencies by the midpoints. So simply slot all that down there and go halfway between each upper and lower class boundaries. So 6, 10, 14 and 18, and grab your calc. Some are easier than others, but I get 32, 108, 190, 378 and 360. Make sure I forgot to answer part A, but there we go. Modal class, most common. So there are more in the 12 to 16 group. Nearly forgot about that. But there it is, done. And to work out an estimate for the mean number of days, total up all them, you get 1,068. Divide by the 100 cars. No need to round off. 10.68 will suffice because that's all it is. Question 2, wordy for no particular reason other than to overcomplicate, really. At the end of the day, the volume of brick A is greater, how much greater? So, in other words, find the volume of this, find the volume of that, and do a takeaway. So, volume of any prism is area of the front bit, the face. In this case, it's a triangle, so it's a half base times height, multiplied by the depth of the shape, or you might call it length, no one cares, times by 5. I get 90 centimeters cubed. And for B, it's half a circle. So it would be pi times, now don't get caught out, the radius is 3, so it's pi r squared for a circle. We've got to halve it for the semicircle, and then times it by again. It's also got a depth of 5. That gives us 22.5 pi. 45 over 2 pi or some other decimal equivalent. And all we've got to do is take them away, giving our answer to one decimal place. So 19.3141 becomes 19.3. Nth term for the first bit, so it's going up in sixes, so you know 6n is part of your answer. And if you write the first few members of the 6 times table down, you should be able to spot that it's up by 4, so 6n plus 4 for your 2 marks. Part B, a couple of ways of going about this. You could just write out each sequence and hope that some coincide, which is fine, but it's dangerous if the number's in 3 digits or beyond, so I'd stick to the algebraic way. So in order to appear in both sequences, we should be able to state that n squared minus 3 must equal to 6n plus 4 at a certain point in time. Let's collect like terms, make it equal to 0, etc. So n squared, take away 6n from both sides, take away 7 from both sides, and this we can factorise to minus 7 and positive 1. That bracket gives you the solution that n is negative 1. Must reject that, because by definition n is the number of the position in the sequence, so it has to start at 1. So the answer we accept is that n equals 7. But it's not the final answer, don't forget, because it wants the number in the sequence, not the position, because n stands for the position. So you've got to sub it back into one of your 2 equations. So 7 squared is 49, take away 3, And just double check that's also in here. So 6 7s are 42, plus 4, 46, confirmed. Number 4, exactly as standard as you'd expect. You've got capital, 7% more, so your multiplier is 1.07, and that's it. He's not doing it for several days. It's not like a bank account interest. That's just it. 11,556. Next one, for accuracy purposes, I have took a screenshot of my doing it on my worked answers, so it's a bit more accurate. I will just come with this with an asterisk. Do be careful, because when you print this off, my printer makes it slightly smaller than what it would have been for the real GCSE, and a lot of schools save money by reducing the A4 pages down to A5, so shouldn't affect the angles when it comes to measuring the bearing, but it will have a knock-on effect on your 154, because it means the P will be slightly further south. So although it doesn't, when you measure an angle that you haven't drawn, that shouldn't change, but this 154 will be affected by P being higher or lower. So just take the mark scheme with a pinch of salt. So part A, a post box is 140 meters. So the scale, we're told, I've cut it off, it would be here, but I've enlarged this so you can see it better. 1 centimetre is 20 metres, so I set my compasses to 7 centimetres, and a bearing of 220, chances are you're using a standard 180 protractor. If you're using an angle measurer, fine. So but for me, instead of going 220 clockwise, as you should do with bearings, I went 140 anti-clockwise before I put my line in and use my scale. Part B, use your scale drawing to find the real distance. So obviously you get your ruler and you measure that, and whatever you get, you times it by 20. So this is where lots of us will have different answers. On my original, I got 7.5. So all I'm saying is that I got 150. The mark scheme allows 150 to 158, but if you've reduced it to A5, you'll be miles out. So as long as your diagram looks pretty good, give yourself the marks. And very similar to part double I, although reducing the size doesn't normally affect an angle, in this case it does, because it means P would be further south if it was smaller, and that will affect your 154. And by the way, the answer's not 154, because just be careful how it's phrased. The bearing of the hall from the post box. So that means you're stood at the post box facing north. So the bearing required is the clockwise turn around there. So if you have a guess at that, it's bound to begin with a 3. So how do we work that out? I measured this angle at the top at the hall. I got 154. That then tells me this, because they're co-interior, whatever you call them, got lots of names, but it tells me that that is 26 degrees, because they add up to make 180. And then once I've got that 26, I do 360 minus 26. So I got for my answer 334. To rubbish 3. The mark scheme allows 330 to 334. But as I say, if your question was reduced to A5, be much more generous. I'd say as long as it looks like mine, give yourself the marks. On we go to number 6. So internal, external angles. So be careful on this one, because the octagon is regular, the pentagon is not. Now, firstly, the pentagon's got a line of symmetry, so these are telling you it is down the middle. So it's telling you that whatever that angle is, that's the same. So let's focus on the pentagon. So to find the total of the internal angles, you take the number of sides and subtract 2. Then you multiply it by 180. So the internal angles of a pentagon should make 540. So your job is to grab your calculator, take away the 112, take away the other 112, take away the 84, get an answer. But whatever answer is shared equally between the two y, sorry. So y is equal to 116. Brings us to phase 2. How big is the internal angle of a regular octagon? So again, you do n minus 2 times it by 180 tells you the total of the internal angles. But this time, because it's regular, they're all equal. So divide it equally between 8. So that gives us 135 for that angle there. And that helps us to find x because that will make that angle 135. We know that y is 119. So x is the difference between them. Subtract them. X is 19 degrees. Number 7. We've got hidden Sokotoa. Why is it hidden Sokotoa? Well, although it's a trapezium, that makes these parallel. But most importantly, it means that the height of that triangle is 15. It means that can be perpendicular. So if I'm going to call it x, if we find x there, we can simply add it on to 37 and we'll be able to find y. Now, how do we find x? Well, we've got one side. We've got this angle because that's also 90 degrees. So the angle at the top is 35. We can now crack on that we want the opposite. We've got the adjacent. The hypotenuse is useless. It's a TOA question. So when we want the opposite, it's tan of the angle. So 35 times by the adjacent 15. And we know that x, therefore, is 10.503. But to one decimal place, we need to add that on to the 37 to tell us that the total of y is 47.5. Number 8. So it starts off laws of indices. As always, one thing at a time. Do 15 divided by 5. And then when it's divided, it subtract the powers. So let's focus on the k's. That's 4. Take away the 1 you can't see to give 3. And for the m, it's 3 take away 2 to give 1. But as always, you don't need to write that. Here we've got a double inequality. That just means do this. When you reason algebra, the key rule in algebra is do the same to both sides. Or in this case, do the same to all 3 sides, if that's how you want to call it. So let's add 1 to everything. Keep the inequalities the same. So you're pretty much there. Let's divide everything by 4. So 18 divided by 4, either 9 over 2. 18 over 4 will do. I'll go with 4.5. Next. Here we are investing. This is like, was it question 2 or 3 with a simple percentage multiplier? So 6,000 multiplied by 1.015 for 4 years gives us 6368.181. But to the nearest That's interest only, by the way, be careful. So it's not 6368, it's 368. Although because of the way it's worded, mark scheme does allow you to have 368.18 or 368.2. But one of them things. Another laws of indices. So another one thing at a time. Square root and power of a half mean the same thing. So job one, square root of 16. Second one, move on to the x's. Power to a power means multiply the powers. So it's 8 times a half. That's a 4. Move on to the y's. So it's 6 times a half. That's a 3. Part B, plenty of things you can do here. For me, I'm going to times everything by 6. Or in other words, by 2 and by 3. So this first term, the 3's cancel, so everything just needs doubling. Now you might think, why am I doing this? I could just jump straight to expanding them out. The reason is to take care with the minus there. All right, there's very much a problem with that minus because you've got minuses times minuses. So in my opinion, I wouldn't rush these. This middle term, we're going to multiply by the 2, so they cancel. So we just need to multiply it by 3. And on the right-hand side, we multiply by 2 and 3 because there's nothing to cancel. Now we can get on with expanding brackets and we can be safe knowing that we're not going to mess up the minuses. So minus 6x plus 9 is 24. Putting the x's together, I get minus 10x. I've got an 8 and a 9, which is 7, sorry, not an 8. Whoops. 16 and a 9, that's 25. Take that away from both sides. Dividing both sides by negative 10, we get a tenth, or if you prefer, 0.1. So for C, always get rid of horrible square roots and stuff first. So square both sides. I prefer to write it over 3. Multiply both sides by 3. I'll cheat a bit there. And divide both sides. We want to make F the subject, so divide both sides by E. But to give your answer, I always prefer to tidy it up. I was just cheating with a bit of crossing out. Number 11. I've said on a previous video, as soon as you see these, even if you don't like them, just try and rearrange, just try and write down some gradients. So for L1, what the heck, Ly? For L1, it's not in the form of y equals mx plus c. I need to subtract 2 from both, I need to subtract x from both sides and divide both sides by 2. Now that tells me that its gradient is negative a half. When we look at L2, we haven't got any equations, we've just got 2 coordinates. So the way to do that, the gradient is delta I over delta x. In other words, changing y's over changing x's. So simply, you don't need to write that, by the way, that's just show you off A-level stuff. You do 9, take away minus 7, and if they're the other way around, doesn't matter as long as you are consistent. Because as long as you put that 7 first, 7, take away minus 1. So on the top, we get a 16. On the bottom, we get an 8. That means it's got a gradient of 2. We haven't finished yet. Is Michael correct? He is correct, but here's why. Because when you multiply the gradients, you get negative 1. And that's a proof that they are indeed perpendicular. And you can quote it just like that. Number 12, boring, but got to put them all in order. So let's just pretend I'm doing it as I go along. 0, 4, 6, 9, 17, 21, 32, 42, 51, 69, 102. And they've picked 11 for a particular reason, because to find, for example, the median, you add 1 and halve it. So your sixth number, 1, 2, 3, 4, 5, your sixth number would be the median, also known as second quartile. So your lower quartile, you add 1 and divide by 4. So that's your third digit, that's your lower quartile, and your ninth digit is your upper quartile. And to find your interquartile range, it's upper minus lower. In other words, it's 45. On we go. Number 13, it's a strange one, and you've got lots of ways you can do this. You could just make up some numbers. Carlos has got £1, 100 pence. Okay, that's exactly how I did it. Carlos, F, so C, F, T. And because everything hinges on Carlos, I gave him 100%. So F's got 65% of, so 65% of 100 is 65, and 22% more for T is 122. Now, they're not the correct amounts, but they're all in the same proportion, and that's the key. So work out how much Carlos got means what fraction did Carlos get. So Carlos gets 100 is his share out of all the shares. So that's the fraction of the cash that C gets. Of means times 861, and it's a reassuringly round answer of £300. Number 14, more laws of indices, but quite weird. Now, don't forget, when you have, I'm sure you've seen the rule before, p to the power of n times p to the power of u or something, you add the powers. All right, you multiply the powers. It's all about this bit, is all about working backwards. It's using your laws of indices knowledge, but in reverse. So let's just ignore the top line. Let's look at what this means. 3 to the power of 2 times x is another way of saying 3 to the power of 2 all to the power of x. Another way, though, would be 3 to the power of x all to the power of 2. You've got to recognise that they are the same thing. The order doesn't matter, because when you've got a power to a power, they just multiplied. So it's the second one we're more interested in. It's the 3 to the x all squared. And why is that? Because we can replace the 3 to the x with a. And that's just it. That's all it's looking for you to make that connection. Part I, your power has been added. They are added when the base numbers have been multiplied. So the x and the 4y got added. But also on that 4y, we're going to replace it with that, using our skills from part I. So as you can see, 3 to the power of x can be replaced with the letter A, and 3 to the power of y can be replaced by the letter B. And they are multiplied, so we can just write them next to each other. And that's the answer to all it wants. Similar for part treble I, we've got 3 to the power of y multiplied by 3 to the power of -1. So 3 to the power of y can be replaced with a b. And what does a minus power mean? it means fraction, it means 1 over, it means reciprocal, so it means a third of. So a third of b, or b over 3. Next up, bit of a weird one. It's kind of simultaneous equations because you've got 2 equations and 2 unknowns, but there you go. The key to it is, look at the difference between them. The only difference between AB and a squared b is an a. It's been multiplied by an extra a. So in other words, if we write them upside down, a squared b over ab, there's an a that cancels, there's a b that cancels, and we'll just be left with a equals this horrible number over this slightly less horrible number. In other words, 81. But don't forget, that's not your answer. That's the answer for A. A is 3 to the x. So now you need to think about 3 times 3 is 9, times 3 is 27, times 3 is 81. So that would be 3 to the power of 4. And once you know that, go back to your original equation, always picking the easiest. So the idea is that if we replace 3 to the x, which is a, with 81, multiplied by b is 2187. So b is 2187 divided by 81. That gives you a nice 27. And let's not forget what b stands for. B really is 3 to the power of y. So same again, what power of 3 is 27? It is 3 to the power of 3, in other words, 3 cubed. Strange one, but not a bad one. Nice revision and a good revision question all round for laws of indices. Number 15. Got a biased coin, so heads is 0.3, so obviously tails is 0.7. What's the probability that he'll get heads exactly 3 times? So that means getting a head, a head, a head, and a tail. But let's be careful, because that's not the only way he can do it. He could have got a tail there, or the tail could have come up there, or it could have been first and been tail and 3 heads. But the fact is, all 4 of them will have the same probability. It's just 4 times them. If the probability does not fluctuate, we can simply do 4 times. Getting a head 3 times is 0.3 times 0.3 times 0.3 multiplied by a tail. And the 4 means we're acknowledging it can be in any order. 0.0756. Part B, work out the probability that the coin will land heads at least once. So that could be a heck of a lot of time and work. It's only worth 2 marks. So your spidey sense should be tingling that there must be a shorter way. And there is. The probability of at least once is 1 minus getting none. Alright, at least once could be once, twice, thrice, 4 times. But rarely adding all them up, it's just 1 minus not getting any. 1 minus tail is really 0.7 to the power of 4. On your calc, jobs are good and 0.7599, and we can move on. So word event diagram, as always on these, take your time. If it takes 5 minutes to smash these, so be it, because there's always lines to come back to. So we've got swimming, basketball, gym, and 120 people. 28 went swimming, so that means 28 are in the swimming circle. So I put that there. so can't put it in anywhere yet. 16 played basketball, same again. That means those will add up to 16, but I can't put any numbers in for sure yet. 27 used the gym, same principle. 3 went swimming and played basketball. That's this section here. So again, I'm kind of locked in that they're going to add up to 3. I'm just going to put a little 3 in there. Can't really fill in. 5 played basketball and used the gym. So basketball and gym again. Cannot fill in any. Just that little I there is going to be 5. 7 went swimming and used the gym. Surely the final one's going to tell us where everything slots in. 2 did the lot. Bingo. 2 goes in the middle. That means it must be a 1 here to add up to that 3. That must be a 3 to account for that 5. That must be a 5 to account for that 7. 5 plus 2 plus 1 is 8. So that must be a 20 to account for that. A 10 to account for that. And a 17 to account for, what did I write down there? 27. Didn't finish off writing, but never mind. It now accounts for that. Be careful though, you ain't finished. You also need to do 120, take away all them numbers, because 62 people sit on the couch. So, one of these people who went swimming. So the idea is, you're now only bothered about the swimmers, and there's only 28 of them. Find the probability they play basketball. That's the crossover, and that's 3 of them. So when it's a given that, it does mean you have to reduce it, so it's not over 120, because we're not looking at those people. Errors and bounds. As I do with all my questions, as soon as you see the numbers, go up and down by half the rounding amount. 0.26 up to 0.265 down to 0.255. Now let's see what we're after. We're multiplying and we want the lower bound. That means make the answer as small as you can. The way you make the answer as small as you can when you are multiplying is pick the smallest possible numbers. 4.75, 0.255, 3 significant figures, 1.21. And seems pretty pointless asking you 2 of these, but it has done so. Let's repeat. 2.73 goes up to 2.735 and down to 2.725. 0.04 goes up to 0.045 and 0.035. This time though, we are dividing. And again though, to find the upper bound, we need to find the largest answer possible, which means we want the largest number on top divided by the smallest possible on the bottom. So we're going to select 2.735 on top and 0.035 on the bottom. Again, 2 sig figs, 78, done. Number 18, me and this electronic pen, I'm going to be here for ages and I'll still mess it up. So I've copied and pasted, I've took a screenshot from my worked answers. So when you are adding a number to the X, horizontally, it's the opposite way round to what you would expect. So x plus 90 means the graph needs to move left 90 degrees. So you pick a coordinate, move it left 90. Same up there, left 90. Pick all the important coordinates. That's the minimums and the point of contact with the axis. And they all shift left 90. Let's get rid of that so I can explain part B. So on part B, two different things are going off. Let's focus on the +3. +3 on the end of a graph will move the graph up 3 units. So the sine curve, it's vertical. Its maximum point is at 1. So if you move it up 3, its maximum will become 4. Assuming it's not being stretched in the y direction, and this x over 2, it would be a stretch in the y direction if the number was in front of sine. So when you've got x over 2, that's actually a stretch horizontally, scale factor of 2. It's stretching it out. All right, it's stretching it left and right, not up and down. So it will simply multiply the x coordinate by 2. So the x coordinate of this maximum point is 90. It's doubling it. It's 180. And why? If you sub it back in, what does 180 over 2 do? It means it's giving you what happens at 90. And that's the logic of what's going on with transformations, in particular stretches. Number 19. So to find the area of these shapes, they are non-right angled triangles, you need to know more things. All right, you need to know other sides, in particular the side DB. Because to find the area of the quadrilateral, it's simply the area of one top triangle plus bottom triangle. So that's going to be, look it up on your formula page, half AB sine C twice. But we don't have enough information. So we have the angle of 58, the side of 9.3, they are opposite. Because we have an angle and the opposite side, we can use the sine rule. So I can state that the side B to D, or DB, divided by the sine of 97 is equal to 9.3 divided by the sine of 58. So bash it in your calculator, 9.3 divided by sine 58, but then multiply by sine 97. We get that BD is 10.884. Answers 1 to 3 sig figs, so I would recommend working in 4 or 5. So now we've got this line here. We actually have, look at the top triangle. You might say, we don't have two sides and the angle between them. Well, actually you do, because you've got 97 and you've got 58. So that angle is 25. So on the top triangle, we've got the angle of 25 and the two sides either side. And on the bottom triangle, we've got the angle of 47 and we've got the two sides either side. So now it's just a case of half AB sine C twice. So area is a half. So top triangle is 9.3, 10.884, and sine 25, and bottom triangle is 11.2, and the 10.884 and the sine of 47. Be careful on your calcs in terms of closing brackets. Some calcs will need you, because they're smart, and open up a bracket. Make sure you close it. As long as you get 65.965, which rounds off to 66.0 to the three significant figures required. Number 20, completing the square. Now, you need to get that 3 out of the way. So I always use a set of square brackets. I kind of ignore the +7. No point in having that in the way. You'll just end up with 7/3. Just gets more confusing. Why bother? That means we can focus on these square brackets. I've divided both terms by 3. We now complete the square in the square brackets. So we halve the number next to x. We square it and take it away. And now you can get back to times in the brackets out. 3 times that shebang. And 3 times that gives us -12 plus the 7 means -5 when simplified. Part B, you'll notice it's the same equation. It's only worth 1 mark because you've done all the heavy lifting. Don't forget that the equation of a line of symmetry goes through the vertex. So the coordinate of the vertex here would be, make the brackets 0, and the y coordinate is what's on the end. So that's the coordinate of the vertex, and sometimes they ask for that, but not here. They're wanting the equation of the line of symmetry, which is a vertical line, and they are x equals, in this case, 2. And that's all it. Nice bit of knowledge. Get it learned. They crop up all the time, but be careful on the difference between what is a vertex and the line of symmetry. Question 21. So you've got an equation, you've got another equation. Find where they intersect. We'll worry about the midpoint later. Let's find A and B. So y equals 6x is what you can take away with that. So let's stick it in. Let's rewrite this top equation, but I'm going to replace y with 6x while expanding these brackets. So I get 10x squared minus 3 times 1 is -3. We do the x terms, so -3x plus 10x gives me positive. So -3x plus 10x gives me positive 7x. And I can now take away 6x from both sides. And you could AC method this, you could use a quadratic formula, all are fine. But like happened on a lot of these videos, 10's not the easiest, but that is, and that is. We've got prime numbers, we've got a 1 and a prime number. So I'll take a stab at 5x and 2x, and it's got to be a 1 and a 3, and it is, it's a -1, and it's a +3. And you can check that by multiplying it out in your head, but always check the x terms for me. That means we get the x coordinate of -3/5 and another x coordinate of a half. And if you're going to pick which equation to sub into, you're going to pick that one all day long, because the y coordinate is just times it by 6. So stick that in your calc. I get -3.6. I've decided to move to decimals. And stick that in your calc, 6 lots of a half. There we go for 3. But you haven't finished. A and B, we've got them. Find the coordinates of the midpoint of A and B. So remember your formula. How do you midpoint things? You find the halfway between the x's. In other words, add the x's together. So I got minus 0.6 and a half. Stick in your calc. Add them together and average them. Same with your y coordinates. Add them together in any order and average them. And you've got your answer. So minus 0.05 and minus 0.3, or the fraction equivalents. Number 22. Strange one, trying to catch you out. It's one of those situations where don't let the volume of the wordiness put you off. Stick to the basics. Think about 45 degrees. Let's not forget that 45 degrees is an eighth of a circle. That's the first thing. Now, when you look at this, you go, there's not enough numbers. I don't know at least one radius. I don't know PA. And that's the crux of it. I'm going to let the radius of the whole thing be R. And when we look at this 3 versus 2 malarkey, that means that O to A is 3/5 of the R, and A to P is 2/5 of the R. Because again, I've said it on other videos, when you get these questions where it doesn't look like you've got enough numbers, just crack on as if you have, because what usually happens is lots of numbers disappear or they work out quite easily. That's how they structure them. So let's just crack on. It tells us that the area of the shaded region is there. Let's crack on. So the area of the shaded region is 81 pi over 2. Let's go back to the diagram. How would you find the area of the shaded region? You would do big slice, and reckon this, minus small slice. That's what you do. Well, big slice is pi multiplied by the radius squared. That's the whole lot. But don't forget, it's an eighth of a full circle, minus the smaller slice. Well, the smaller slice is also pi, is also an eighth, but this time its radius is not R, it's 3/5 of R. Like so. Whoops. And first thing you'll notice, the pi's can cancel to make life a bit simpler. Once we've got that, I don't like this 8 thing, so I times everything by 8 just to tidy it up and get it all on one level. So I'm left with R squared here minus 3/5 squared is 9 over 25. R squared is R squared. But hey, look what you've got here. R squared minus R squared. So you need to do 1 minus 9/25. That will give you 16/25 R squared is equal to 324. In other words, we can now work out R. So to get R, take your 324, times it by 25, divide it by 16, and square root your answer. You don't need the negative square root because the radius can't be a minus. So we get R to be 22.5. What does that also help us with? That means if you find 3/5 of that, that's there. That's 13.5. And 2/5 of that is 9. So you've now got all the numbers that you need. Because what does it actually ask for? It wants the perimeter. So the perimeter of the shape, let's just scroll up a bit. The perimeter of the shape is going to be straight edge, that's 9, and another straight edge, that's 9, plus big arc, plus little arc. On we go. So perimeter equals the 9 plus the 9, plus the small arc and the little arc will both be 8ths of a circle, and the circumference of a circle is 2 times pi times the radius, and 2 times pi, times the larger radius. And believe it or not, it wants the answer in terms of pi, because all that shebang, stick it in your calc, leave the pi out of it, divide it by 8, don't forget, you get 18 and 9 pi centimetres. Job done. Very long-winded question, didn't need the extra sheet, but it's worth 6 marks. Don't throw all 6 marks away. At least try and set something up. Don't forget, it's essentially area of circles. It's fractions of it, and if you don't know R, let it be a letter. Let it be a number. Could have called it 10 or something, and just got on with it. You might have blagged a couple of marks, and 2 out of 6, when you don't like a question, is far from a disaster. And finally, so the 10th term. So let's use notation. The 10th term is a plus n minus 1. So that's 10 take away 1. Lots of the difference is 66. Done. The sum of the first 20. You've got a formula for that. It's on your formula page. It's n over 2. So 20 over 2. In other words, 10. 2 lots of your first term. Take 1 away from 20. 19 lots of your difference is equal to 1,290. We've got a 10 here and a 10 there. Let's get rid. So we've got 2a plus 19d equals 129. We've got simultaneous equations, and we're going to double the top one, because watch what happens. 2 lots of a, 9 2s are 18, 2 66s are 1 3 2. And if we do top take away bottom or bottom take away top, no one cares. You will end up with d equals minus 3. If you end up with minus d equals 3, same thing, just switch the signs around. That means we can work out a. So a plus 9 lots of negative 3, in other words, minus 27, is 66. So we get the first term of this sequence to be 93. But now we can actually answer the question. Find the 5th term. So the 5th term, T5, will be a plus 4d. So it's the first term added, but it's because d is a minus, we'll stick it in there. 4 lots of 3. And that's the easy bit, 81. So yeah, those sum to whatevers, those terms whatevers, they're ultimately posh simultaneous equations, and they will be at A level as well. Anyway, what'd that take? 54 minutes and counting, so I'll shut up and I'll say I hope that's helped, and I'll see you on the next one.